Today's lesson has been brought to you by Limitless Learning TT. For additional videos as well as more information on our services offered, please visit www.limitlesslearningtt.com. You can send us an email at limitlesslearningtt@gmail.com, or you can give us a call at 868-354-3115. Today we will be answering a trigonometry-based question from the May-June 2013 Cape Pure Maths Unit 1, Paper 2. The first part of our question asks us to show that sine of 2 theta is equal to 2 tan theta divided by 1 plus tan squared theta. I'm going to use the right-hand side of the equation and then work down and show that it's equal to the left-hand side. So starting with the right-hand side, now from our trigonometric identities, we know that our denominator, 1 plus tan squared theta, is the same thing as sec squared theta. So therefore I'm going to replace the denominator with sec squared theta. This is the same thing as 2 tan theta multiplied by 1 over sec squared theta. And we remember that cos theta is equal to 1 over sec theta. So therefore, cos squared theta is the same thing as 1 over sec squared theta. So now I can replace my fraction 1 over sec squared theta with cos squared theta. I can also recall now that tan theta is the same thing as sine theta over cos theta. And now therefore these can cancel and I'll be left with 2 sine theta cos theta. And 2 sine theta cos theta is the same thing as a sine 2 theta, which is equal to my left hand side. So therefore I have shown that my right hand side is equal to my left hand side. So therefore this question has been completed. 3a part 2 says, hence or otherwise solve sine 2 theta minus tan theta is equal to 0 for the range of thetas between 0 and 2 pi inclusive. So from a part 1, we know that sine of 2 theta is the same thing as 2 tan theta over 1 plus tan squared theta. We just showed that. So therefore I can replace my sine 2 theta with that part. So I'm going to replace sine 2 theta with 2 tan theta over 1 plus tan squared theta. Next I'm going to take my tan theta over to the right hand side. Next I'm going to multiply both sides by 1 plus tan squared theta to get rid of 1 plus tan squared theta in the denominator. Next I'm going to expand my brackets on the right hand side. And now I'm going to put all of my terms together to get tan cubed theta plus tan theta minus 2 tan theta. And that's going to give me tan cubed theta minus tan theta is equal to 0. Now I'm going to clean this up by factorizing. I'm going to pull out tan theta since it's common to both terms. And within my brackets here, this is the difference of 2 squares, so I can further factorize that. So now I have 3 factors. I have tan theta is equal to 0, tan theta minus 1 is equal to 0, and tan theta plus 1 is equal to 0. Now we recall the range that we're looking for solutions. It is between, theta is between 0 and 2 pi. Right, that was given to us as our range. So looking at our first factor, tan of theta is equal to 0. That must mean that theta is equal to tan inverse of 0. So therefore our solutions for theta between 0 and 2 pi would be 0 pi and 2 pi. Let's look at our second factor, tan of theta minus 1 is equal to 0. That must mean that tan of theta is equal to 1. So theta is equal to tan inverse of 1. And if tan theta is equal to 1, that means that tan is positive, and tan is positive in quadrants 1 and 3. So therefore, our solutions for theta will be pi over 4 and 5 pi over 4. Let's look at our last factor. Tan theta plus 1 is equal to 0. So that must mean that tan theta is equal to negative 1. Tan is negative, so that means that we're looking for solutions in quadrant 2 and quadrant 4. So theta is going to be equal to the tan inverse of negative 1. So theta is equal to 3 pi over 4 and 7 pi over 4. So the solution to our answer would be this one, and this. So theta is equal to 0, pi, 2 pi, pi over 4, 5 pi over 4, 3 pi over 4, and 7 pi over 4. So B part 1 is asking us to express f of theta, which is equal to 3 cos theta minus 4 sin theta in the form r cos of theta plus alpha, where r is greater than 0 and theta is and alpha is between 0 and pi over 2. So we want to put 3 cos theta minus 4 sin theta in the form r cos theta plus alpha. So now we're going to expand the cos of theta plus alpha, and that is cos theta cos alpha minus sin theta sin alpha. And if we distribute r, we get r times cos theta cos alpha minus r times sin theta sin alpha. So now we could equate both sides. That must mean that 3 cos of theta must be equal to r cos theta cos alpha. So therefore, that must mean that 3 is equal to r cos alpha. Then that must also mean that 4 sin theta has to be equal to r sin theta sin alpha. So therefore, 4 must be equal to r sin alpha. Therefore, r sin alpha over r cos alpha has to be equal to 4 over 3. So therefore, sine over cos is going to give us tan, and r's are going to cancel. So tan of alpha is going to be 4 over 3. Therefore, alpha is going to be tan inverse of 4 over 3, which is 0.927 in radians. Also, if we're going back to this point here, if 3 is equal to r cos alpha, then we can square both sides. So that will give us 9 is equal to r squared cos squared alpha. And we're going to do the same thing for this. If 4 is equal to r sin alpha, we can square both sides. That's going to give us 16 is equal to r squared sin squared alpha. And now we can add both of these together to get 9 plus 16 is equal to r squared cos alpha plus r squared sin squared alpha. So therefore that means 9 plus 16 is 25, and that's equal to r squared into cos squared alpha plus sin squared alpha. And we know that cos squared plus sin squared is equal to 1. So therefore 25 is equal to r squared, and r is equal to 5. R can't be negative 5 because of the range that the question gave us for r. R must be greater than 0. So therefore now we have a value for r, which is 5, and we have a value for alpha, which is 0.927. So we can do what the question said, which is to put it in the form r times cos of theta plus alpha. So therefore, 3 cos of theta minus 4 sin theta is equivalent to r, which is 5, cos of theta plus alpha, which worked out to be 0.927. So this part has been completed. So now we're on to B part 2. Hence find the maximum value of f of theta. So f of theta is equal to 3 cos theta minus 4 sin theta. And we found out from the previous part that that is equal to r, which is 5 cos of alpha, cos of theta plus alpha, which worked out to be 0.927. Right, so question asks us to find the maximum value of f of theta. And maximum will occur when cos of theta plus 0.927 is equal to 1, because that's the maximum value of a cos function. So therefore, the maximum happens when this is equal to 1. So therefore, the maximum for f of theta will occur when this is 1. So therefore, the maximum value of f of theta will be when 5 is multiplied by the max of this cost function, which is 1. So therefore, our answer is 5. Part B asks us to find the minimum value of 1 over 8 plus f of theta. Now we know that a fraction is the smallest when its denominator is its largest. In order for the denominator to be its largest, it means that f of theta must also be its largest. We just found out that the maximum value that f of theta can be is 5, so therefore the largest that f of theta can be is 5, so the minimum value will be 1 over 8 plus 5, which is 1 over 13. That's our answer. So the last part of our question, given that the sum of the angles A, B, and C of a triangle is pi radians, we need to show that sine of A is equal to sine of B plus C. So we were given that A plus B plus C, those angles are all going to be equal to pi. So therefore, A is going to be equal to pi minus B plus C. So now I'm going to solve my question. I'm going to start with my left-hand side, which is sine A, and I need to get that to be equal to sine B plus C. So let me start with my left-hand side. Now we can replace A with pi minus B plus C. So that's going to give me sine of pi times cos of B plus C minus cos of pi times sine of B plus C. Now we know that sine of pi is 0, and 0 times anything is 0. Also, cos of pi is negative 1 times the sine of B plus C. And now a negative by negative, negative 1 by negative 1 is going to give me positive 1. So my result is sine of B plus C, which is equal to my right-hand side. So we've shown that sine of A is equal to sine of B plus C. And the final part of our question is to show that sine of A plus sine of B plus sine of C is equal to sine of A plus B plus the sine of B plus C plus the sine of A plus C. So I'm going to recall what we would have just proven in part A, that sine of A is equal to sine of B plus C. So therefore, that must mean that sine of B is equal to the sine of the other two angles, and that sine of C is equal to the sine of the other two angles. So if I were to substitute sine of A is equal to sine of B plus C, sine of B is equal to sine of A plus C, and sine of C is equal to sine of A plus B into my original equation here, I should get my right-hand side. So let's start with the left-hand side. So sine A is equal to sine of B plus C, sine B is equal to sine of A plus C, and sine of C is equal to sine of A plus B. And that is equal to my right-hand side. So that's it for this question. So we would have completed number 3 from the May-June 2013 CAPE Pure Math Unit 1 Paper 2. For additional videos as well as more information on the services we offer, once again you can visit our website at www.limitlesslearningtt.com. You can always send us an email at limitlesslearningtt@gmail.com or give us a call at 868-354-3115.